Let us see the next example of linear homogeneous type of recurrence relation equation. Next example of question is determine constants C1 and C2 such that recurrence relation equation is given that un plus C1 into un minus 1 plus C2 into un minus 2 is equal to 0 has the characteristic roots given are 1 plus minus square root of minus 1. इथे तुम्हाला रिकरन्स रिलेशन इक्वेशन दिलेलं आहे un प्लस C1 इंटू un मायनस 1 प्लस C2 इंटू un मायनस 2 इज इक्वल टू 0 आणि याचे रूट्स सुद्धा गिवन दिलेले आहेत 1 प्लस मायनस स्क्वेअर रूट ऑफ मायनस 1 आणि तुम्हाला C1 आणि C2 या इक्वेशन मधल्या C1 आणि C2 चे जे कॉन्स्टंट आहेत त्यांचे व्हॅल्यू फाइंड आउट करायला सांगितलं. मग हे फाइंड आउट करण्यासाठी जे गिवन इक्वेशन दिलेलं आहे ते अगोदर आपण लिहून घेतलं un प्लस C1 इंटू un मायनस 1 plus C2 into un minus 2 is equal to 0 and mark this equation as a first equation. Then the given roots of this equation are 1 plus minus square root of minus I. Square root of minus I is also called iota, that is denoted by I sign. Therefore 1 plus minus square root of I write as I symbol because I is equal to square root of minus 1. Therefore two roots of this equation are alpha, first root alpha is equal to 1 plus I and second root beta is equal to 1 minus I. Then we know the properties of two roots alpha plus beta is equal to alpha value plus beta value, that is 1 plus I plus 1 minus I, plus and minus I cancel terms and 1 plus 1 answer is 2, that is alpha plus beta is equal to 2 value we get. And similarly alpha multiplied by beta, that is the product of two roots, is equal to 1 plus I multiplied by 1 minus I, that is we get the answer is equal to 2. If alpha and beta are the roots then the equation will be, जर अल्फा आणि बीटा हे तुमचे रूट्स असतील कोणत्याही क्वाड्रॅटिक इक्वेशनचे तर त्याच्यावरूनच तुम्ही क्वाड्रॅटिक इक्वेशन असं लिहू शकता z² मायनस अल्फा प्लस बीटा इंटू झेड प्लस अल्फा इंटू बीटा इज इक्वल टू 0. मग याच्यावरूनच z² मायनस ॲज इट इज लिहून घेतात आणि अल्फा प्लस बीटाचा आन्सर तुम्ही 2 काढलेला आहे ते इथे पुट केलं अल्फा प्लस बीटाच्या ऐवजी 2 इंटू झेड ॲज इट इज प्लस ॲज इट इज आणि अल्फा इंटू बीटा प्रोडक्टची व्हॅल्यू पण तुम्ही कॅल्क्युलेट केली आहे 2 मग ती सुद्धा इथे पुट केली म्हणजे नेक्स्ट क्वाड्रॅटिक इक्वेशन आलं तुमचं z² मायनस 2z प्लस 2 इज इक्वल टू 0 and mark this equation as the second equation. Now our question is un plus C1 into un minus 1 plus C2 into un minus 2 is equal to 0. This is equal to 0 means function f of n value is equal to 0 means this is a linear homogeneous type of recurrence relation equation of order is 2 because the un values depends up to n minus 2. Therefore order of this recurrence relation equation is 2. Therefore we can write firstly this equation in the z format, that is z raised to power 2 plus C1 as it is z into z plus C2 as it is equal to 0. This equation marked as third equation. For the coefficients value find out C1 and C2, we solve this equation and find out the value of C1 and C2. Then we get the value C1 is equal to minus 2 and C2 is equal to 2. When we solve this equation and find out the value of C1 and C2, then we get C1 is equal to minus 2 value and C2 is equal to 2 value. Let us see how to solve the linear non-homogeneous type of recurrence relation equation. If the equation in the form alpha 1 raised into n an plus alpha 2 into an minus 1 plus up to alpha k plus 1 into ak is equal to f of n. If f of n, that is function value, is not equal to 0, then given equation is called non-homogeneous recurrence relation equation. Then to solve the non-homogeneous type of recurrence relation equation, some general solution formulas are given. If function value is c means any constant term means f of n value is 1, 2, 3 any constant term, then general solution formula is only a, that is an is equal to a. Then if function value, that is f of n value, is any n, that is f of n value is only n, then general solution of this formula for this general solution of the non-homogeneous recurrence relation equation is a1 into n plus a0 multiplied by n. Then if the function f of n value is n square, then formula for general solution equation is a2 into n square plus a1 into n plus a0. And lastly, if the f of n value is given r raised to power n means r at the place of r any number, that is 2 raised to power n, 4 raised to power n, then we use the general solution formula as a into r raised to power n. To solve the non-homogeneous type of reconciliation equation, the main formula is an is equal to an raised to power h plus an raised to power p. Means h means homogeneous part and p means particular solution part. To find out the solution of non-homogeneous type of reconciliation equation, firstly we have to find out homogeneous solution of this given reconciliation equation, and then particular solution of given non-homogeneous reconciliation equation, and lastly we add these two terms to find out the solution of given non-homogeneous reconciliation equation. म्हणजे जर तुम्हाला कोणत्याही प्रकारचं नॉन होमोजिनियस रिकन्सिलिएशन इक्वेशन सॉल्व करायचं असेल तर त्यासाठी तुम्हाला अगोदर त्याचं होमोजिनियस सोल्युशन फाइंड आउट करायला लागेल, नंतर पर्टिक्युलर सोल्युशन फाइंड आउट करायला लागेल आणि नंतर हे दोन्ही सोल्युशन्स एकत्र करून तुम्ही ॲडिशन करायची आहे आणि हे ॲडिशन करून जे तुमचा आन्सर येईल तेच तुमचं लास्ट सोल्युशन असेल लिनियर नॉन होमोजिनियस टाइप रिकन्सिलिएशन इक्वेशनचं. लेट अस सी सम एक्झाम्पल्स ऑफ linear non-homogeneous type of reconciliation equation. So the first example is an plus 2 plus 3 into an plus 1 plus 2 into an is equal to 3 raised to power n with initial condition values are a0 is equal to 0 and a1 is equal to 1. We know that to find out the solution of linear non-homogeneous type of reconciliation equation, our formula is n is equal to n raised to power h plus n raised to power p. Means firstly we have to find out homogeneous solution part and then we have to find out particular solution part. So firstly we have to find out the homogeneous part, that is n raised to power h. We write down equation n plus 2 plus 3n plus 1 plus 2 into an is equal to 0. Because the in homogeneous part function value is 0, then we call this equation as a homogeneous type of reconciliation equation. So we can write this equation in the form of r raised to power n plus 2. So we can write n as r raised to power n plus 2 plus 3 as it is write down, n plus 1 as r raised to power n plus 1 plus as it is 2 as it is write down, n as r raised to power n is equal to 0. Then to find out the value of roots, we just divide this equation by r raised to power n. When you divide each term of this equation by r raised to power n, then we get the next equation as r square plus 3 into r plus 2 is equal to 0. Then we solve the roots of this quadratic equation. Then we have to find out roots are r plus 2 multiplied by r plus 1 is equal to 0. Then first root value r1 is equal to minus 2 and second root value r2 is equal to minus 1. So if the roots are distinct, that is distinct real roots, given roots of the given equation as r1 is equal to minus 2 and r2 is equal to minus 1. Therefore given roots of the equation are distinct, that is different roots, then the general solution of this equation, homogeneous part of this general solution equation formula is a into alpha 1 raised to power n, that is r1 raised to power n, plus b into alpha 2 raised to power n, that is r2 raised to power n. So the first factor we get it minus 2 and second factor is minus 1. So put the r1 and r2 value in that equation. Then we get n raised to power n, that is homogeneous solution as a into minus 2 raised to power n plus b into minus 1 raised to power n. Next we have to find out particular solution of given reconciliation equation, that is n raised to power p. So we write down the question n plus 2 plus 3 into n plus 1 plus 2 into n is equal to 3 raised to power n. This is a given reconciliation equation given in question. Then in that equation f of n, that is function value, is equal to 3 raised to power n. It is the equation in the form of a into r raised to power n. Therefore a into r value is 3. In that, from this equation we can write r value is equal to 3. Therefore a into 3 raised to power n. Put n is equal to a into 3 raised to power n in that equation. Therefore particular solution of this equation n raised to power p is equal to n plus 2 as it is write down, plus 3 into n plus 1 plus 2 into n is equal to 3 raised to power n. Then just put an is equal to a into 3 raised to power n in that equation. Just in the next step, जेव्हा तुम्ही a च्या जागी a into 3 raised to power n व्हॅल्यू पुट कराल, म्हणजे इथे a च्या जागी जर a into 3 raised to power n व्हॅल्यू पुट केली तर हे a into 3 raised to power n येईल आणि प्लस 2 ॲज इट इज वरती पॉवरमध्ये लिहायचं आहे, प्लस ॲज इट इज साईन, त्यानंतर 3 ॲज इट इज मल्टिप्लायमध्ये, त्यानंतर a च्या जागी a into 3 raised to power n व्हॅल्यू पुट केली a च्या ऐवजी, प्लस 1 ॲज इट इज पॉवरमध्ये लिहिला, प्लस 2 ॲज इट इज लिहून घेतला, a च्या जागी a into 3 raised to power n इथे सुद्धा व्हॅल्यू पुट केली आहे, इज इक्वल टू 3 raised to power n ॲज इट इज लिहून घेतला. आता ह्या सगळ्यामध्ये तुम्हाला रूट्स फाइंड आउट करण्यासाठी किंवा a आणि b च्या व्हॅल्यू फाइंड आउट करण्यासाठी 3 raised to power n व्हॅल्यू ही कॅन्सल व्हायला पाहिजे. त्यासाठी या पूर्ण इक्वेशनला 3 raised to power n ने बोथ साइड्सने डिवाइड करूया. डिवाइड केल्यानंतर नेक्स्ट इक्वेशन येईल 3 square into a प्लस 3 into a into 3 plus 2 into a is equal to 1. Then 3 square answer is 9 into a plus 3 into 3 9 into a 9a plus 2 into a 2a is equal to 1 as it is. 9a plus 9a plus 2a, 9 plus 9 18, 18 plus 2 20a is equal to 1 as it is. Therefore a value we get as a is equal to 1 upon 20. Then to find out the particular solution of this equation, we know the fn value is 3 raised to power n. Then we know the formula. If the fn value is 3 raised to power n, that is at the place of r, the given question value is 3 raised to power n. That is 3 raised to power n. If fn value is 3 raised to power n, then our homogeneous solution of this particular solution of this non-homogeneous part of equation is a into r raised to power n. Therefore, we use this formula NP, that is particular solution of the given recurrence relation is equal to a into 3 raised to power n. Then n particular solution is equal to s value we put on this equation 1 upon 20 into 3 raised to power n. Therefore, we get all two terms, that is homogeneous part solution and particular solution part. So, therefore, the total solution of given recurrence relation equation n is equal to n homogeneous part plus n particular solution part. So firstly we get n homogeneous part, that is a into minus 2 raised to power n plus b into minus 1 raised to power n plus as it is sign, and particular solution part just add it 1 upon 20 into 3 raised to power n. Next we have given values a0 is equal to 0 and a1 is equal to 1. So finding the value of a and b, we just put value a0 is equal to 0 and a1 is equal to 1 in given our solution. An is equal to a into alpha 1 raised to power n plus b into alpha 2 raised to power n plus 1 upon 20 into 3 raised to power n. So put value n is equal to 0, then we get equation as a0 is equal to a into minus 2 raised to power 0 plus b into minus 1 raised to power 0 plus 1 upon 20 to 3 raised to power 0. Then a0 value given is 0, we put this a0 value as 0 is equal to a into minus 2 raised to power 0, answer is 1, that is a multiplied by 1, answer is a, plus b into minus 1 raised to power 0, answer is 1, b multiplied by 1, answer is b, plus as it is 1 upon 20 as it is 3 raised to power 0, answer is 1, therefore 1 upon 20 multiplied by 1, answer is 1 upon 20, write down. Therefore, a plus b is equal to, we get value as a plus b is equal to minus 1 upon 20. So, write this equation as equation first. Then, next we put value n is equal to 1. That is, a1 is equal to a into minus 2 raised to power 1 plus b into minus 1 raised to power 1 plus 1 upon 20 into 3 raised to power 1. Then, put just value of a1 given 1 in that equation. So, next equation we get as minus 1 is equal to a into minus 2 raised to power 1, answer is minus 2 into a, minus 2a, then minus 1 into b, minus b, that is next answer minus plus minus sign, therefore minus b, plus as it is 1 upon 20 into 3, multiplication answer is 3 upon 20, then next equation we get as minus 2a as it is, minus b as it is equal to sign 1 minus 3 upon 20, then 2a minus b is equal to, answer we get as 17 upon 20. So mark this equation as second equation. To solve these two equations, we just write down a plus b is equal to minus 1 upon 20. That is first equation. Then write down second equation, minus 2a minus b is equal to 17 upon 20. After solving these two equations, plus b and minus b terms are cancelled. plus a and minus 2a answer